So if you've ever tried to get a large language model to give you data that your software can actually use, you know the pain. You need this nice, structured, reliable output, but instead you just get a wall of text. Well, today we're going to dig into the solution that's finally making AI applications robust and predictable: function calling.
Just imagine this for a second. You ask a model a simple question. Hey, compare the weather in Tokyo and Berlin. Now, the model can't just browse the web on its own. To answer you, it needs to call a weather API, right? Probably twice. But to do that, it has to generate a perfectly formatted, structured API request. And that, right there, is the core of the challenge.
So that brings us to our first section, what I call the structured data problem. Honestly, it's a wall that pretty much every single developer hits when they first start trying to build real things with LLMs.
You see, at their heart, LLMs are incredible at generating natural, free-form language. It's what makes them so powerful. But that very strength, that flexibility, becomes a massive headache for our software. Your application doesn't want a conversation. It needs predictable, structured input that's the same every single time.
Okay, so developers, being developers, started coming up with workarounds. Let's jump into our next section and see how we went from just wrestling with raw text to getting a lot closer to a real solution with things like JSON mode.
In the early days, you really had two options. First, there was plain text completion. You'd beg the model in the prompt to give you what you want, you'd cross your fingers, and then you'd write a bunch of really fragile code to try and parse the output. If the model added one extra sentence, your whole app could just break. The next step up was JSON mode, which was a huge improvement because it guaranteed the output would be valid JSON. But, and it's a big but, it still didn't solve the entire problem.
And this quote right here just perfectly sums up the issue. This is the exact kind of subtle bug that drives developers completely crazy. With JSON mode, you could ask for a field named category, but the model might give you back cat instead. The JSON itself is perfectly valid, but your code, which is hard-coded to look for category, just immediately fails. You still don't have a guarantee on the schema.
And this is where the real game changer comes into the picture. Section 3. Enter function calling. And let me tell you, this isn't just another prompt trick. It's a fundamental shift in how we get data out of these models.
So what is it really? With function calling, you, the developer, get to define the exact output schema down to the last detail. You specify the field names, the data types, even the exact allowed values for a field. You're not just suggesting a format anymore, you're forcing the model to stick to a strict contract.
Let's look at a really concrete example to make this real. Say you're building an email classifier. With a function calling schema like this one, you can demand a category field that must be either sales or support, and nothing else. You can require a confidence field that has to be a number between 0 and 1. This isn't a request, it's a rule that the model literally cannot break.
Now, this all sounds great, maybe a little too great. How is it even possible? Well, this brings us to the most fascinating part of all, Section 4, how the magic actually works. Let's pop the hood.
This is the key question for any engineer, right? We know that these language models just generate text sequentially, one token, like a piece of a word, at a time. So how in the world can you enforce these complex, rigid rules on a process that seems so fluid?
The answer, the secret sauce, is a powerful technique called constrained decoding. You might also hear it called guided generation. And the really crucial part to understand here is that this isn't happening after the fact. The constraints are being applied in real time during the generation process itself. You know what? Here's the absolute best way to think about it. Imagine you're filling out a smart web form online. If a field only accepts numbers, you literally can't type a letter into it. The form just won't let you. That is exactly what constrained decoding does to the LLM.
Let's just walk through it step by step. Let's say the model gets to that category field from our email example. It checks the rule, the value has to be sales or support. At that exact moment, the system dramatically limits the model's entire vocabulary. The only tokens it is allowed to choose from are the ones that can start the words sales or support. It is fundamentally, physically impossible for it to generate anything else. That is the guarantee.
Okay, so that's the how, which is super cool. But now for the so what. Let's move to our final section and really talk about why this all matters for building stuff in the real world. Look, function calling is so much more than just another feature. It is the critical bridge that we have needed for so long. It finally connects the powerful but, often chaotic world of natural language with the rigid, structured world of our software, of APIs, and databases. So what's the big takeaway for you as a developer? Well, first, you get guaranteed structure. No more guesswork. That means you can finally stop writing all of that fragile, custom parsing code that breaks all the time. This reliability is what makes it possible to build AI agents that can confidently talk to other tools and APIs. In short, this is what makes AI production ready.
And that brings us right to our final thought. For years, the unreliability of LLM output has been a huge blocker, a deal breaker, really. But now that we can guarantee structure at the most fundamental level, it just opens up a whole new frontier. So I'm going to leave you with this question. If we can finally build that reliable bridge between language and code, what can't we build?